Alright, so this is a video to go over the Chapter 3 practice exam. Not the Chapter 3 practice exam, our practice exam 3, which is over chapters 5 and 6. So some key points when going through this exam over chapters 5 and 6 is I really want you to show all of your work, right? And when I ask you for an exact value, I want you to leave it as a radical. For a lot of these problems, you could use your calculator. It's not going to give you the correct answer. Okay, so it's always nice to have the little calculator security blanket, but it's not going to be super helpful here. So first off, we've got to find the 6 trigonometric values in radians for cosine theta equals negative square root of 3 over 2. So in this case, well, there's a couple things. One, we know negative square root of 3 over 2 is our cosine when theta equals 5 pi over 6, or when theta equals 7 pi over 6. So I didn't really specify, right? So what I go ahead and do in the key is I find it for 5 pi over 6, and I am going to specify for what angle I want you to find theta. So I have, looking at my unit circle, that sine of theta equals positive 1/2, because we're in quadrant, this is in quadrant 2. Cosine of theta was already given to us. I can calculate the tangent of theta by taking y over x, which is 1/2 over negative square root of 3 over 2. That equals 1/2 times 2 over the square root of 3, but that's a negative, so I get negative 1 square root of 3. But we do not like radicals in our denominator, so final answer is negative square root of 3 over 3. Cosecant of theta is 2. Secant of theta is 1 over, is 1 over cosine, which is going to be 1 over negative square root of 3 over 2, which gives me negative 2 over the square root of 3. Final answer, negative 2 square root of 3 over 2. So this is all from chapter 5. And then cotangent of theta is x over y, which will give me a negative square root of 3. For problem 2, let's pick a happier color. For problem 2, I want you to find the amplitude. The amplitude is the absolute value of this leading coefficient, so our amplitude is 3. Our period is 2 pi divided by omega. This is omega. This is psi, right? Well, that would be 2 pi divided by 2, which is pi. And then our phase shift is psi over omega, which is 2 pi over 4 over 2, which would be pi over 8. And I didn't ask you to graph the equation in this case. For problem 3, I want you to find the value of sine theta exactly without finding theta, given that our tangent of theta is 3/4 and our cosine theta is less than 0. So our cosine theta is negative. That means our sine is negative as well. So that puts us in quadrant 4. Nope, sorry, quadrant 3. That's where everything's negative, is in quadrant 3. So if I have x squared plus y squared equals r squared, that's 4 squared plus 3 squared equals r squared, 25 equals r squared, 5 equals r. So the exact value for sine of theta is going to be y over r, which is 3/5. But I have to remember that sine is negative because sine's negative, cosine's negative, but my tan's positive, so I've got to put a negative sign right here. For problem 4, I want to verify this identity. So I have 1 minus sine of alpha over cosine alpha plus cosine alpha over 1 minus sine alpha. Sorry I didn't go to the trouble to make a PowerPoint for this, guys. It's been a day. So we're going to work it out on the iPad. So I want to add these. I have to do that by finding the least common denominator, which is cosine of alpha times 1 minus sine theta. Sorry, alpha. Keep the symbol the same. That gives me 1 minus sine alpha cosine alpha plus cosine alpha times 1 minus sine alpha. Nope, cosine alpha times cosine alpha. I messed that up. So in order to get this to have a denominator that looks like this, I have to multiply by 1 minus sine of x. So I've got 1 minus sine x squared minus cosine x. And then in order to get this to look like this, I have to multiply by cosine of x. So it's going to be cosine x times cosine of x. Then we FOIL everything out. I got 1 minus 2 sine theta alpha plus sine squared alpha plus cosine of squared alpha. Come on, I can write there. All over cosine alpha times 1 minus sine alpha. Okay, so friendly reminder that sine alpha plus cosine alpha is 1. So we're going to substitute. Let's go down here. So I have 1 plus 1 minus 2 sine alpha over cosine alpha times 1 minus sine alpha. That gives me alpha 2 minus 2 sine alpha over cosine alpha times 1 minus sine alpha. That equals 2 times 1 minus sine of alpha over cosine alpha 1 minus sine alpha. And then these are going to cancel. So I have 2 over cosine alpha. Well, 1 over cosine alpha is secant. So I have 2 secant alpha.